So, Faisal sir, you can start now slowly. Okay. Meanwhile, one or two candidates are also joining. Okay. So, meanwhile, you can start a little bit. Okay. Let me make you the host, sir. And you can make me the co-host.
Okay, sir. Okay. Mhm.
You can make me the co-host, sir.
Okay, 1 second. Co-host, host.
Okay. All right, guys. So, sir, you can start, right? And I'll be here for some time, Faisal sir. I'll be drop in case of any need you have. You just call me or drop in the group. Okay. Somebody's going to help you.
Okay, Suresh also joined.
All right.
So let us share the screen. Oh, 1 second. I'm getting a call. Just wait, guys. I need to attend this call. 1 second. Sorry, guys. I had a call. Okay, let me share the screen. So yesterday we have discussed some basic things related to the networking. Is screen is visible, right? Hello.
Yes, visible.
Yeah. Okay. So we have discussed like what is network and how it is working. Some basic steps we have discussed, that how it is connected, how internet is working, and what is the purpose of network, and what is wired network and wireless network, and how we can design a network. We have discussed so many things yesterday. Not so many things, but some basic things. Okay, today we can take the topic topology. There is a topic that is topology. It's a physical and logical layout of connected device in a network. See, the way the devices are connected, there are too many ways. Older days, there was different method to connect devices. Like there is bus topology, we have star topology, ring topology, tree topology, mesh topology, and hybrid topology. In these topologies, nowadays we are using only three topologies. That is, a star topology, and mesh topology, and another is tree topology. These are the three topologies which we are using right now. The other topologies are there, which was used in older days or previous days, okay, on the beginning of this network era. Nowadays, so we will be discussing all this topology, but you just want to understand that all these topologies are not required for us because it's not using nowadays. We have only three topologies right now, that is star, tree, and mesh topology. Okay, now if we discuss about this bus topology, it's there would be a centralized backbone cable. I can see draw here, 1 second. Hmm, you can, okay, let me take the pen tool. So as I told you, we have different topologies. What are those? The older days we had bus topology. And what is this topology? How the devices are connected in this topology? See, there would be a centralized cable. Okay. There is a centralized cable, and both the end there would be a terminator which will terminate the cable, and in between there would be T connectors. Okay, why do we need this T connector? To this T connector we are going to connect the devices. For example, one device will be here. One device would be here. This centralized cable would be a coaxial cable. Okay, and one device would be here like this, and they are communicating through this. Okay, by the way, see here, if anything happens in this cable, for example, some damage occur here, the entire communication will be lost. This cannot communicate here, this cannot communicate here, this cannot communicate here. So this is the problem. Troubleshooting is very difficult in this topology. This is the first topology which was introduced in starting of this networking. That is, troubleshooting is very difficult, and it is costlier because we are using coaxial cable, and we have terminators. We need some T connectors to connect to the end devices. So it would be costlier, this topology. Okay, would be costlier. And one more thing, the speed which we are getting if we use this topology will be also very low. That would be like 10 Mbps, I think so. Can see here the speed which we are getting is, yeah, 10 Mbps. Left side you will see that, and it's costlier, and we have different material which we are using in this bus topology. One is T connector, and we need a cable connector in PC side to connect the cable from PC to T connector, and we have what at the end of the cable we will have a terminator both sides. So it would be a costlier setup. Okay, and here you will be getting a speed which will be very low, that is 10 Mbps only. Okay, this is what bus topology, and nowadays we are not using this. And you can see here it uses a centralized cable, and that cable which is known as backbone cable, that cable would be a twisted pair cable or coaxial cable. Okay. and we can move to the next topology, that is, star topology. We are using this topology right now. Okay. So in small network, for example, network where we are having only less number of user, suppose we have 50 user or 100 user. So this topology, for example, we have in our network, we have only 40 users. So we'll be having a switch. Yesterday, I told you that switch is a centralized device where we are connecting all our devices to have the communication between the devices. Okay, so this is a centralized device. Why we need a switch? Because if you want to connect multiple device, for example, this is two device. If there is only two device, we have an option to connect both by using a single Ethernet cable. Okay. Imagine that there is one more user. Sorry, one more user is there. So that user also would be having an Ethernet port. You can see that in your laptop also there would be an Ethernet port where you can connect the Ethernet cable. Okay. If there is one more device, it is difficult to connect with this network, right? We have an option like if you install one more network adapter here, you will be getting one more Ethernet port and we can connect like this. But imagine we have one more user. So what will happen? Again, we need to install network adapter. It's not recommended way and we cannot install that much adapter in your laptop or desktop, whatever it is. You would not be having that much space in your devices. So to connect, to have the connectivity between multiple devices, or you can say that more than two devices, you need a centralized device. That is what switch. Okay. Switch, you will be having a detailed portion or section in switching. Okay. Where you will be studying all the steps related to the switching and all. Right now, you just want to understand that it's a centralized device where the users can connect and they can communicate between each other. So this is the switch. Hmm. Okay, where we are connecting our devices. So in this topology, what is happening, and this would be, imagine that it's a switch. This is a switch and this is the physical representation. Physically, it would be like this, and you will see the port requesting to record to the computer. Apply this one. See, requesting.
Yeah, I am the one. Just request. Can I record it to my computer? So
Can
if
you,
I miss something,
Vishal sir is there? Just
okay.
allow.
Yeah.
Vishal sir is there in the meeting or he left? Uh, Let me check with him. 1 second. Mhm.
Hi, Faisal, sir. Am I audible?
Yes, sir. Shibu is requesting to record to their computer. Can I click on
No, no, no,
approve?
no. It is going to record on the backend side, so no need to allow any recording. Sibu, this is going to be recording is going to be provided to you via our portal. Okay, Sibu?
Okay, okay, okay.
Okay, so recording is going to be provided to you via our app and the website. So you're going to get that. So local recording is not permittable as per the company policy.
Okay, sir. Okay.
Okay, thank you. Thank you.
So let us continue the session. So here in this topology, so this is what star topology we are going to discuss that. So here we will have a physical device that is, the switch. And I told you that why we need a switch in a network. And see here, all the devices are connected in a way that, see, all the ports are here. You can see the ports which is present in the switch. You can see that physical view here, and all the ports will be connected to a centralized point like this. Okay, here my cursor is moving, like, see here, all these ports are connected to a centralized point, and that connection will be look like, should that would be look like a star topology. That is why it is known as star topology. Physically it looks like a star. Okay, and logically you can represent this like this. Here centralized device switch is here, and all the wire is connected to the or each and every devices. You can see that this is logical representation and this is the physical representation. Here you can see that if you are having only less number of staffs, like 50 or 100 staffs, if 100 staff is there, maybe you need like, three switches in your network, because the normal switches are like, that would be having 24 ports or 48 ports. Okay, there are switches like MLS switches, and which would have large number of ports, but we are discussing the basic things. So the normal switch, which would be having only a 24 port or 48 port switch. So if you are having 48 ports, you can see, you have to use how many switches for 100 user. 48 plus 48 would be 96. So 96 is not enough for 100 user. So we will be having three switches, and we will connect all our staffs to these three switches. How it would be connected? Like, here I can show you that. See here, if you have 100 user, I'll be having three switches. Each one is having 48 ports. For example, these are the three switches, and each switch would be having how many user? Imagine that I connected 30 users in each switches. For example, these are the my switches are there in the IT room or server room or rack, whatever it is, and your users are sitting here. Imagine that all these 30 users are connected to this switch, and another 30 user would be connected to this switch, and another 40, 30 plus 30, 60 plus 40, 100. Okay, so all the 100 users are connected to three switch, and from this switch there would be a connection to this and to this, so all the devices can communicate. So here it's a small network. There are only 100 devices, and you can terminate or all your cables are terminated to a single IT room. All your 100 cables will be coming to this room. But this 100 cable, imagine that if somebody is having some problem, imagine these devices cannot communicate to these devices, or else you can say that there is a router. I told you that if we need the internet connection, we'll be having a router. It's a layer 3 device which would be helping to connect to the internet, and will be having a detailed session about this router also. Right now you just want to understand that it's a device which would be connecting different network. Okay, so if this device or your staff need to access the internet, there should be a router in your network. Okay, that router is this, and imagine that this staff is not getting internet. Okay, he is not getting internet. So what you will do, you will check the connectivity from here to here. So how you will find out the cable? Here only you have 100 cables, right? 100 cables, because I told you that the number of users are low here. Only there is 100 users, and you can find out which cable is having problem easily, because you have only 100 cables which will be coming to this room, right? From this 100 cable, you have to trace the cable which is connected to the staff who is not getting the internet. So you can find out easily from this 100 cable, and if there is any cable fault, you can remove the cable and you can put the new cable. So the troubleshooting, as it is a small network, we can use this star topology, and here the troubleshooting will be very simple. Okay, easy. Troubleshooting easy, not difficult, because the number of cable which we want to trace, if anybody is having the problem related to the communication or related to internet is not working, so you can trace it out the cable very easily. Imagine that all the devices not getting internet. Okay, consider a scenario where all the staffs are not getting internet. Here we have 100 users, and when they are trying to access the internet, no one is getting the internet, and you want to find out the issues. If everybody is having problem, there would not be a cable issue, right? 100 users are having problem means the problem is not in the cable. The problem would be where 100 device, there is no chance. Imagine that this first 30 user is having problems and they are not getting the internet. So the problem would be in this switch. Okay, the first switch, we can do what? We can replace this switch within 5 minutes. Okay, within 5 minutes, if you have a switch, spare switch, you can replace this switch and you can make the network up. Okay, imagine that this 20 or 40 user is not getting. The below users are not getting the internet. So where you will check? You don't want to check the cable because everybody is having the problem. You don't want to check the port of the switch because why? Everybody is having the problem. So the problem would not be in switch, sorry, in the ports or in the cable. The problem would be in the switch. So again, you can replace this switch in 5 minutes. So what you understand here, that is, the troubleshooting is very easy in this topology. That is what star topology, and it would be used in LAN network, in our private network or in our company's network. If it is a small network where we are having only less number of user, we can use what? Star topology. And what is the benefit of having this topology? That troubleshooting is very easy. You can say troubleshooting is very easy. And another thing is that you will be getting 100 Mbps second speed, and 100, sorry, 100 or 1000, one second. Yeah, 100 mbp, 100 or 1000, it depends on the port type. If it is a fast ethernet port, there is a different type of port also, like you will be in the switches, you can have like a fast ethernet port which will be providing you a speed of 100 mbps, or if your switch is having gigabyte port, you will be getting how much speed? 1000 mbps. Okay, 1000 mbps means 1 gigabyte per second. So the speed is also high if you are using this star topology, and the troubleshooting is also very easy. And another thing is here, I told you that if any problem exists in the switch, we can replace that switch in 5 minutes. That is also an advantage of this star topology. So you can have this topology in a small network, okay, where we are having only less number of users, we having a centralized device that is known as a switch, and the physical connectivity of this topology would be like, here you can see that this is the physical representation, and this is what logically it would be like this, okay. So this is the third topology, which is known as star topology. Now we can move to the next topology, that is, ring topology. It is also an old topology, okay. We are not using this topology nowadays, it's already expired, okay. So how the devices are connected in this topology, you can see the physical representation and logical representation. I can redraw this picture. uh, okay, here this is the third topology. We have discussed the first one. We discussed what? First topology was bus topology, and the second one is what? Star topology. Star topology, we are still using this, and the third one is what? Bus topology. And in this topology, how the devices are getting connected. See, there is a device that is MAU. MAU means multi-access unit, MAU. Okay. There is a device, multi-access unit, and that device would be having some ports where we are.
One question, please.
Hello? Yes?
Hello. You said the third topology is bus or ring.
Sorry. No, it's ring. Okay. It's writing error. Okay. Ring topology, and where we are having a device that is multi-access unit, and this device would be having different port, and here how the ports are connected means in such a way that like, from here to this port it would be connected like this, and from here to here it would be connected like this, and here to here it would be connected like this. For example, if there is a device, imagine there is a device here also. So if this device want to send the data to this device, the data would be sending to the port, then it would be sending to this port, then to this, and like this. It will not send directly to this port, because in this ring topology only clockwise traffic traffic is allowed only in a clockwise direction. For example, when traffic reaches at this port, it would be sending to this port in a direction how the clock is working. How the clock is working, it would be in this direction, right? So the same thing is
Is it they
happening.
are using for that? Is it they are using any token?
Yeah, token is system is also there. I'll be coming to that. So the direction here is clockwise. When a traffic hits on this port, it would be sending to another ports in such a way that clock is working. So the traffic would be reaching to the second port, then to third port, then like this, these devices. Okay. And if this device want to send the data to this device, again, it cannot send like this, or it cannot send here. No, it would be sending in a clockwise direction. Once it reaches here, it would be sending to this, then to this. Okay. So clockwise direction is only possible in this topology. And here you will have some points, and the logical representation, why it is calling as ring means here the connection between the ports are in a form of ring, right? I draw here. I'll be redrawing that again. 1 second. See why it is known as ring topology, because in this multi-access unit, ports are connected in such a way that, for example, we have some ports. I told you that ports are connected to this, then to this, then to this. So this is forming a ring. That is why it is known as ring topology. And this is the physical representation. If you need to represent logically, which would be like this, like we will have some devices. We'll have devices here and here and also here. So it is connected in such a way that the ring is formed. Okay, so all the traffic would be sending in clockwise direction, and there would be, as you told, there would be a token system. Only one person can send at a time. Like, if this device, for example, this topology is not using nowadays, so you don't want to worry about this. You just want to understand these things. This is an older topology. Older days this topology was there, but nowadays it is not there because of so many limitations. Okay, so when this is, suppose the device A wants to send the data to device D, this device will take the token and he would be sending in clockwise direction. Once it would be sending to B. Then, for example, here source is what? A, the destination is D, right? A need to send the data to D. So this traffic would be sending to B. We will check the destination. Who is the destination? D. So B will get to know that no, this traffic is not for me. So B will be redirecting this traffic to next person. He would check the destination again. Destination is what? D. So C also will be getting rejected, and C would be forward this traffic to D. Once the traffic reaches at D, he'll be checking the destination. Okay, destination also same, and he will be accepting that traffic, and he'll be giving the reply back with source as D and destination as A. So you may think that they would be replying in this direction. No, cannot, because I told you that ring topology is working only in clockwise direction. Again, D would be sending the data to this direction with the destination as source, sorry, the destination as A. Once it reaches at the device E, it would be checking that destination, and they come back to that destination, and he will get to know that it is not for him, and he will move forward this traffic to the device A, and the device will get the reply. This is how the traffic is flowing through this topology. And this would not be using nowadays. Okay, and here you will see that some points related to this, that is data will be traveling in a clockwise direction, and there is a token system where the sender will accept the token and send to the receiver at the same time. No other can send data as token is busy. If the token is busy, no other device can send the data at the same time. Okay. Is this what ring topology? This topology is also not using in nowadays. You can see that MAU devices right side of this PPT. Here, this is an old device. MAU means multi-access unit. Okay. So we have studied three topology. So now we come to what tree topology. Here the logical representation of tree topology you can see here. It's like a tree, so that is why it's known as what tree topology. And where we use this tree topology means one second. Okay, here This topology would be using in a network where we are having thousands of users. Okay, I told you that in small network we have a topology that is star topology, which would be used in every network where we are having less number of users, like 100 users, 200 users, because that tracing the cable, if the problem is there in a network, imagine that we are having 200 users and one user is not getting the internet, and we'll be checking all the physical connectivity, and you will be, if the problem is there in the cable, you will be tracing out the cable. How you trace? By using some tracing instrument, we can find out the cable which is faulty, and you can replace that. If there is low number of cable, it's okay to do that. But imagine in your network, if there is thousands of users, or 2000s of users, or 5000, or 10K, whatever it is, the tracing of cable would be very difficult if you use what? You use the star topology in a larger network. Okay, means what I'm saying is, if there is imagine that there are 5000 users in your network. So imagine you are going to do what? You are going to use the single IT room, as in the case of uh, star topology, where you are having how many switches you need to connect. Imagine 2000 user. If you are having 2000 user, and if you have a switch of 48 ports, how many switch you need to connect 2000 users? Suppose you need to have how many users? 40, right? 45 or 50. Imagine that 50 switches you need. So all the 50 switches you are connected in such a way that all the user is connected to this network. Imagine what is happening here. The problem in this method, this is a star topology. I'm not going to use tree topology right now. I just want to inform you the problems where we are facing in a star topology if you are using in a large network where we are having thousands of users. I have taken 2000 users, so all the users are sitting here, whatever it is. Imagine these are 2000 users, and what will happen? All these 2000 cables would be coming to a single room, right? Single IT room. There are 2000 cable coming from the users, and which would be terminated to the switches, right? Imagine any of the user is getting problem, so is having the problem, and the problem is he's not getting the internet. So what you will do? You will check that physical connectivity first, right? And you will do some troubleshooting, and by using some commands and whatever it is, you will be checking that, and see, after that you will be checking the physical connectivity also. So when you check that physical connectivity, imagine that this device is having problem, and he also would be connected to this somewhere in the switches, right? So how you can trace out this cable? There are how many cables are there? 2000 cables are there. From these 2000 cable, it is very difficult to trace out the cable which is faulty, right? It is very difficult because there is how many users? Sorry, how many cables are there? 2000 cable. Okay, so the find out the faulty cable, it is very difficult in star topology if there is large number of users, like thousands of users. So what you will do here? Using you will not use star topology in a larger network. Instead of using this, you will do what? You will have another option, that is tree topology. So how tree topology is working? So entire 2000 device, you will be dividing into like sections. For example, 2000 device, you will be divided like 5 section. Okay, sorry, or 10 section you will divide it. Here all these 200 users are sitting. Here another 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 200. Another 200. Again here also same thing. Another 200 device. Here also. So here also another 200. 200. How many are there now? Total 400, 800, 1200, 1600, 2000, right? Divided entire staffs into different section, and each section would be having 200 staffs now. And what will I do? I will be giving connectivity to this each and every section separately. Like, for this 200 user, I will have how many switches we need? Like, we need, for example, 5 switches. So I'll be having a uh, IT room or whatever it is for these 200 users, and you will have 5 switches inside this IT room. For example, I'll be having 5 switches here. Imagine that switches are connected in vertical or horizontal, whatever it is. So all your 5 switches are here, and all 200 users are connecting like this. Now, this section, again, there would be an IT room for this separate section. There also would be having 5 switches, and each and every user will be connecting to this. So how many cables are there in each section? Only 200, right? Again, we will be having switches here for this section. 5 switches, all these cables are connected here. Again, we will have another 5 switch here, another 5 switch here. So each and every section will be having a different IT room or server room or whatever it is, and all these devices are connected to these switches like this. And now, so here this section is connected by using this, and this connection, this devices are connected in this section. But from this section to this, there is no communication. How you can make the communication? You will be bringing another switch here. Okay, you'll be bringing another switch here, and you will connect one switch here and one switch here. So from here to here, now the communication is possible. So this also, you will have another switch in your IT room, and switches would be connected like this. And this first one, where we connect our device, we can call it as there is some architectural hierarchy like access switch, and which would be a basic switch. And this one, where we are connecting different switches, that would be distributed as layer switch. And here also, like, this one would be having some medium configuration. Okay, like more than this access switch. And again, here also switches would be connected, and this section also will be interconnected. Here also there would be access switch to connect the device, there would be access switch to connect the device, and also there would be a distributed, okay, distribution layer switch also like this. So Now what is happening? This device can communicate. This section can communicate each other. This section also can communicate. This section also communicate. This also communicate. But from this to this, not possible. So again, we will be having another switch. One core switch would be having here, and we'll be having a connection from distribution. All the distribution layer switch would be connected to this centralized core switch, so that every section are connected like this. So what is the benefit of doing like this? Here, if somebody is having any problem, for example, if this guy is having problem like he's not getting the internet, so you just want to go to this server room which is related to this section, and you will be having only 5 switches there. And how many cables would be there? Only 200 cables, and you can trace out the cable which is faulty. Okay, so here troubleshooting is very easy. So you would be using this tree topology in a network where we are having thousands of users. Okay, you should not use star topologies there, because all the cables will be terminated to a single IT room. If there is thousands of users, 2000 user or 5000 user, how you can trace out? It is very difficult to troubleshoot if you are using star topology in a big network, okay, in a larger network. So here in your, if you are having a larger network, you'll be having certain architecture like this. You will be having access switch, distribution layer switch, then you will connect that distribution layer to the layer switches to the core switch. And here troubleshooting is very easy, as we are having only less number of connections in each and every section. Okay, so this is what tree topology, and logically you can see it's like a tree. That is why it's known as tree topology, and logically you can represent tree topology in this way. Okay, troubleshooting is very easy. And you can see here that in small network we use what? Star topology, and in large network we have to use tree topology. So the topologies which we are using nowadays is, you got the two topologies. One is star topology, which we can use in smaller network, and we have tree topology, which we can use in larger network. Okay. So this is what tree topology. Now we can move to the next topology, that is mesh topology. So mesh topology you will not see in LAN side, your company's network, you will not see the mesh topology, but you will have this topology in WAN side. How means I can redraw this picture. See mesh topology we are talking right now. So in this mesh topology, how that connection would be there, like, suppose I have my company is having 4 branches. One is in India, for example. I have a branch here. Devices are getting connected to the switch, and I have a router to access the internet, and it should be connected to the internet service provider. Okay. I have another branch in another location. For example, it's in Dubai. Okay, and I have connected to that branch would be having a router to connect to the internet, and it would be having a switch from router. There would be a connectivity to the switch. From there, it would be connected to all the users. Now, I have another branch in US. Okay, so this is my branch in US, and that also connected to the internet service provider which is available in US. Okay, Now I have another branch which is in UK. So again, the connectivity to the internet service provider, which is available in UK, and we will be having a router, and then to the switch, and all our staffs are connected to this switch. This is the way we are having branch, and we are having the connectivity, and all your branches is connected to the internet. And as I told you that all the internet service provider are interconnected. Because of that only you are getting the access to all the website which is available in the world. Okay, for example, when you access Google, you are getting that. When you access YouTube, you are getting that. When you access Facebook, you are getting that without any problem. So why it is means every internet service providers are connected. For example, this would be connected here, this would also would be connected like this to this ISP, and again this would be connected like this would be connected to this would be connected to this would be connected to this. All the ISP internet service providers would be interconnected. If this fail, there is another path. There is another path. Multiple path would be there. Okay. So here, how these ISPs are connected. See, this is the way our ISPs are connected. This way is known as what? Mesh. Okay, mesh topology. How the ISPs are connected. Okay.
Hi, Professor.
Hello.
I have a quick question.
Yeah.
So that means technically we are using mesh for a wide area network.
Yeah. Yeah.
Okay.
We are using this mesh topology in wide area network in WAN side. Okay, we'll be having this topology. So you can see that logically the same thing. If you are going to represent in logically, you can represent like this. We'll be having devices. You can just make a device, and that devices are connected like this. Okay, in a mesh, same like this. This is the original representation, physical representation, and logically by using the device you can represent like this. Mesh topology can be represent like this. Okay, and in you know that WAN side we would be using fiber optical cable. Okay, there would be multi-mode fiber, single mode fiber. We'll be studying that. Okay, so the topology which we are using right now is what? Star and the tree topology in LAN side, and we are having mesh
Mesh.
topology in WAN side. Okay, the other topologies which are there like a bus, ring, and one more topology is there, that is what? Hybrid topology. What is happening here in this hybrid topology means, there would be a combination of mixed topology, which means what? Like we have, I told you that previous days or in starting of this era, we were having the bus topology, we were having ring topology. So the hybrid topology means the combination of all these topologies, like we'll be having bus, we'll be having ring, we'll be having star. So this topology is also not using nowadays. Why? Because bus is not there, ring is not there, then how hybrid is there? So hybrid cannot exist, right? So we cannot use the multiple combination of topologies that would not be there because bus and rings are not there. So and I told you that you know that here in WAN side we can use what? Mesh topology, and in LAN side we can use um, star and tree topology. So here we are having only three topologies which we use nowadays, that is star, tree, and mesh. Okay, so let us move to the next topic, that is networking devices. So you would be having some knowledge regarding this. So what is this? There are like different devices which we use in the networking, which we use in networks. That is, The first one you can see here, it's the LAN card, and we'll be having starting of this era we had hub, the device hub, and then it moves to the switch, and for to connect multiple network they introduce another device, that is router, and to provide the security we have firewall and gateway. It's also like it's a device. I'll be explaining that, I'll come to that. And we are having access points. So these are the examples of some networking device which we are having in the network. Okay, so now we can move to the first one, LAN card. What is LAN card, guys? LAN card, if you are having the laptop, if you check your laptop, right side or left side, you will be having a port where you can connect the Ethernet cable. You will be having an RJ45 port. You can see if you are accessing the Zoom right now in your laptop. If you check most of the device, almost 90 percentage of the devices would be having this port, this port you can see there in your laptop. Maybe some laptop would not be there this port, because it supports only Wi-Fi. Okay, in that case, if you want to connect a cable to the your laptop, you will have another option. You just want to buy this adapter. Okay, there is an adapter which is available in the market, and one side of this adapter would be USB and other side would be RJ45, same like this. Okay, so you can connect this USB this adapter to the USB port, and other side you can connect the RJ45 cable and then to the device. So even if you don't have that port in your laptop, you will have an option. Sorry, guys, one cockroach came. Okay, you will even if you don't have that RJ45 in your laptop, you can add this physical adapter to your laptop, and you can make your laptop to connect the cable. Okay. So here these are that wired option, so you can connect that cable to this port, and this is known as what, LAN card, wired LAN card. And we are having, I told you that some of the laptop would not be having this wired LAN card, but there would be uh, wireless LAN card would be there. Okay, without that, without wired and wireless, no laptop will come, I hope. Okay, there would be either wired card or wireless, or most of, like 90 percentage of the device would be having both wired and wireless LAN card. So wireless LAN card is like this. There would be a chip here, like, yeah, and there would be like antennas here, and here you cannot see this in your laptop. It would be there inside your laptop, and your wireless signal would be catched by this. That is why you are getting the Wi-Fi. Sorry. A Wi-Fi in your laptop. So I just, yeah, I'm moving the cursor here. This is what your Wi-Fi. So if you are getting the Wi-Fi, which means you will be having this LAN card, Wi-Fi LAN card, okay, which would be looks like this. Or even if you don't have this Wi-Fi LAN card, I told you that there are this adapter also available in market to connect as a wireless, like to enable that wireless connectivity. You'll be getting that wireless adapter from that market, and you can connect that adapter. One side of the adapter will be what, USB, and other side it will capture the signal, wireless signal. So this is what LAN card, and it can be wired, and it can be what, wireless. So here you will see that LAN card and wireless LAN card and wired LAN card. Okay, this is just like a SIM card. LAN card, it would be having, see, your SIM card will be having a serial number, right? Same like that, your LAN card would be also having a serial number, that is known as what? That is known as MAC address. Like in a SIM card, you will be having serial number, not that mobile number. Okay, there would be a mobile number associated with that SIM, but apart from that, there is one more number that is known as serial number. Every SIM card, each and every SIM card which is delivering to the customer will be having a serial number, unique serial number for each SIM. Same like that for each and every network adapter, when they doing the manufacturing, or when the manufacturers are making this LAN card, they will assign a MAC address to the LAN card. That also would be unique. No MAC address would have the same MAC. Sorry, no LAN card would have the same MAC address. Okay. The MAC address which would be associated to the network adapter would be unique. Okay. So wherever you are having the LAN card, there would be having a MAC address also. Each and every LAN card would be associated with a MAC address. That is same like serial number in the SIM. Okay. Now we can move to next slide.
Yeah, Faisal, sorry to stop you.
Okay, tell me.
Yeah, I have a doubt here.
Mm.
Yeah, what is the difference between this MAC address and IP address?
Yeah, I'll come to that point. No problem. We have a detailed session related to the IP address. I will just move my slide. You can see here. Once we complete this networking device, we'll be moving to IP address. When we discuss this, all your concept will be getting clear. Both are different. MAC address is different and IP address is different. Okay, just now
Yeah.
you just want to understand that both are different, and we'll come to that point, no problem. So
Yeah, one more
here,
thing.
yeah, here also I'll be saying that there is two type of address in LAN card. One is physical address, and it open on. One is physical address, and the other one is logical address. Physical address means what? It's a MAC address, and it's a 48-bit hexadecimal address. Physical address will be represented in hexadecimal format, and logical address it's a 32-bit decimal number. Just wait, I'll have a moment. Please give me a moment. I'll come back. Okay.
Yeah,
Mm,
Faisal, one more thing.
one
Here
second.
yeah,
Okay, let us start from where we stop. Okay, so we are having what? LAN card, and LAN card is having two addresses. One is physical address, and other one is logical address. So what is physical address? It's a 48-bit hexadecimal address. So why do we, how it is represented? Why we call it as hexadecimal? Because if you check your MAC address, for example, I'm having the laptop and you can see my command prompt, and I'm going to type get MAC. This is the command to check your MAC address of your laptop or whatever it is. Okay, it would take some time, might be seconds. Okay, so your display, you can see here, media disconnected means I didn't connect the cable here to my LAN port. That is why it is showing media disconnected. And there is so many adapter you can see, because I have an application like VMware workstation, and I have added so many network adapter in this application. That is why it is showing different MAC address. So for example, I can show you my network adapters by using commands ncpa.cpl. So it will be redirecting to this adapter section where we are having different adapters, VMware network. That's why when I type get MAC, it's showing multiple MAC address. But you just want to check the MAC address where it is showing media disconnected, because I didn't connect the cable. That is why it is showing media disconnected. I didn't connect any Ethernet cable to this port. So you can see here it's a MAC address and it's represented in CE4A8DF. So this is what hexadecimal. Okay, I can see. I just want to rewrite. So hexadecimal format here, it is MAC address is what? E4A8DF and B39E. This is my MAC address. Okay, so why it is calling as hexadecimal? Because what is hexadecimal format, how it looks like. For example, you know that hexadecimal number will be 0 1 2 3 4 5 6 7 8 9. Then it will be coming to A,
A,
B, C, D,
E.
E, F. It is representing like this. Okay. So this is what you can see here in your MAC address. You can see A is there. You can see D is there. You can see E is there. You can see F is there. F is not the right. F is there. So which means it's a
It's
hexadecimal
base of
format.
16. Base of
Yeah.
16, so we are following hexadecimal.
Mm. So if we want to convert this hexadecimal into bits, how it will be? Like 000 0001. For 2 in bit format, you can represent 0010. For 3, you can represent 0011. For 4, you can represent 0100. For 5, you can represent 0101. For 6, 0110. For 7, you can represent 0111. For 8, you can represent 1000. For 9, you can represent 1001. For A, you can represent 1010. And for B, you can represent 1011. And for C, you can represent 1100. And for D, you can represent 1101. And for E, you can represent 1110. And for F, you can represent 111. So this is what hexadecimal, and this is corresponding bit format for this hexadecimal number. So if you check the MAC address, you will find this A and B and C. So it is known as what? It's represented in hexadecimal format. And 48-bit means what? I told you one hexadecimal bit is 4 bit, right? One hexadecimal bit is 4 bit. One hexadecimal 4 bit. One hexadecimal number is 4 bit. So how many hexadecimal number is there? 2, 4, 6, 8, 10, 12. 12 into 4, which means 48. That is why MAC address is what? It's a 48-bit hexadecimal number. You can see here 48-bit hexadecimal number. And the representation It is an example, and I have shown you that how it would be look like in my laptop also. You can see that. And the logical address, it's another type of address which is available, and that is what IP address. And by using MAC address, we cannot communicate between the devices. You have to understand that with by using the MAC address, we cannot communicate. Like, by using the serial number of SIM, can we communicate? Can we call to another guy? No. You will be having what? You should be having a mobile number, right? Same like that in laptops and desktop, whatever it is, network devices, we need to have an address to communicate between each other. That is what IP address. MAC address, by using MAC address, you cannot communicate, and but if you want to have the communication between the devices, you should be having what? Logical address, that is known as IP address. And that is what earlier days, it was a 32-bit decimal number, IPv4. Then nowadays we are using IPv6 also. I'll be coming to that. Right now you just want to focus on this 32-bit IPv4 number. And so logical, it's a logical address, and it is a 32-bit decimal number. But when I talk about the MAC address, I said that it's a 48-bit hexadecimal number. Now I am saying that IP address or logical address, it's a 32-bit decimal address, which means what? Same like that. I'll be drawing again. Let's see. Like IP address will not be, IP address would be, for example, if I want to represent an IP address, it would be like this, or I can represent like this. I can represent like this. These all are IP address. I'll be coming to that IP address in detail. You just want to understand that what I'm saying here is, can we see any letter A or B here? No, you cannot see that. You just want to, you are watching what? You are seeing what here? You are seeing only some numbers. These numbers are what? Decimal number. Decimal number is what? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Integer number, like it will be continuing. Okay, so if you are having that, if you want to represent an IP address, you have to use what? Decimal number. And if you have the MAC address, you will be finding hexadecimal number there. Okay, so it's represented in decimal format. And I said that it's a 32-bit number. Okay, 32-bit means what? For example, if I'm having like 32-bit means, here I told you that a total of one hexadecimal is represented by 4 bit, right? Here, one decimal number will be represented by 8 bit. For example, if it is 1, it would be like, 0, 0, 0, 0, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8. And another also, if it is 1, okay, 1, you can represent 1.1.1. My IP address is this one. Imagine that 1.1.1. So it would be, how it would be represented in this bit format, 2, 3, 4, 5, 6, 7, 8 dot. This is decimal format. Now I am going to convert this to binary format. You know that the device will be knowing only about the binary numbers. They don't know this decimal and all. But it is very difficult to remember the binary number for us humans. It is very difficult to say. See, if I say that IP address is 00110000000011, it's very difficult, right? So that is why, for us, they did what, we can use the decimal number, but computer will convert. It will convert when you enter an IP address. It will immediately convert it into binary format. For example, one will be represented by 0001, and this one also would be represent 0001, and another thing 45 sorry. So another thing 4 5 6 7 8, another 4 5 6 7 8. So here you can see how many bits are there. This is 8-bit. This is also 8-bit. This is also 8-bit. This is also 8-bit. So this is what IPv4 address, and it will be in decimal format. And how many bits are there? 32-bit. That is what here it is mentioned. So by using MAC address, we cannot communicate, or we don't have the communication between the devices if you don't have IP address. So by using the IP address, if you want to have the communication, we need to have what? IP addresses. Okay, you can see here I have taken the two devices, device A and device B, and I assigned IP address here like 10.1.1.1 to one device, and I'll be come to that like IP address, how we can represent an IP address. There is a detailed session. So here you just want to understand that we have to assign the IP address to have the communication. So I hope you got that difference between this IP address and MAC address. And MAC address, it's assigned by whom? Manufacturers there would be. So, and IP address also, there is a team who is uh, developing this IP address, or who developed this IP address and all. That is what? IANA. Okay, Internet Assigned Numbering Authority, who is having the responsibility to um create this, or to generate the IP address and all. Okay, they only generate that IPv6 also, because of we are having large number of requirement nowadays in the world. It is not enough to use only the IPv4 address, because there are billions of website available in the world, so that IPv4, it's not enough. So we'll be having what? IPv6, and we'll be having a detailed session on IPv6 also. Don't worry about that. So we are on the starting now, and now we are talking about the networking devices. And the first one is LAN card. And I told you that in LAN card, we'll be having different kinds of LAN card. We'll be having wired LAN card. We'll be having wireless LAN card. And if you don't have that adapter, we can use that. Sorry, if you don't have built-in network network card, you can use adapters. Wired adapter is there, wireless adapter is also available in the market. And in LAN card, we'll be having two type of addresses. One is physical address, and the other one is logical address. And I told you that if you want to have the communication between devices, the MAC address is not enough. So you will be having to use what? IP address to have the communication between the devices. Okay. So how IP address is assigning, or how we have to give that IP address. So that one we will be discussing in IP addressing session. Okay. Now we go to that another networking device, that is hub. Hub is also nowadays we are not using that. Okay. I told you that before, when we are having more than two device, we have a device switch, right? That one I told you already. So before the invention of switch, there was another device that is known as hub. It's a non-intelligent device, like there would be like hub device, and hub also will be having ports. Okay, your device will be connected to that port, And for example, we are having three devices A, B, C. When A need to send data to C, the traffic would be sending to hub. Hub will do that. Hub will be sending to each and every port. Hub, I told you that hub it's not an intelligent device. It will not check anything. Once it get the packet or traffic on any port, it would be sending to all the ports where it is where the device. It will not check where the device is not connected. It will not check the port where the device is connected or not connected. No, once a traffic reaches at a port, it will be sending to all the remaining ports. This is what hub is doing. Okay, so when a traffic, for example, A need to send a data to C. So hub will do what? Hub will send this data to B, and hub will also send this data to C. So B will be getting that and B will be checking the destination. B will reject that, but C will be accepting that. This is the older networking device where we can connect the advantages. We can connect multiple devices, like more than two devices. Okay, so this was there before the invention of switch, but we cannot do this. We cannot use this nowadays as it is not intelligent. And I told you that when a traffic hits on the ports of this hub, it would be redirecting to every port. Okay, well, it will not check that port is connected to a device or it is not connected to a device. No, it is not, it doesn't matter. Okay, hub will send to all the port. So this is what hub, and we are not using this nowadays. Can see here it's used to connect two or more devices, more than two devices. And here, and one more problem in hub is it cannot we cannot send and receive, or it cannot send and receive the data at a time through hub. Okay, because the collision would occur there. I told that it's non-intelligent device. It cannot find out any collision or whatever it is. No, so it can send only means if someone is sending, the other device cannot send. If it send that, other device also send the traffic will get collided and it will get lost. So it's an unintelligent device, and we cannot use this nowadays. Okay, it is if only sending and receiving is not possible at the same time, means half duplex device. Hub is working in half duplex mode. Okay. Then now see, after the hub will be having another centralized device that is known as switch. Switch is an intelligent device. Okay, not like hub. For example, I told you that when a traffic hits on the ports of hub, that traffic would be redirecting to all the ports, right? I told you that just before. But switch is doing what? For example, if you are having a switch, the purpose of switch also is to connect multiple devices. That is same, but switch can do uh, more like functions, which can have large number of function. Or yeah, like for example, if I'm having multiple devices which is connected to the centralized device known as switch. So, for example, A, B, C, and D, and the port number which is connected to this device is 0 bar 1, 0 bar 2, 0 bar 3, and 0 bar 4. So here, what will be happening, in switch there would be having a table that is you can say that CAM table or MAC address table. So I told you that it's an intelligent device. So in this table, there would be having what the device A is connected to the port number 0 bar 1, device B is connected to port number 0 bar 2, and device C is connected to port number 0 bar C, and device D is connected to port number 0 bar 4. So when a traffic, imagine that device A wants to send a data to device C. Okay, this is the traffic and which is generating from this device, and this device would be sending the traffic. Once it reaches to this port, switch would be checking that the destination is located where. So where the switch will check the cam table. We'll be coming this session in detail, but right now I just want to inform you that switch is an intelligent device. Why? What is the reason we call it as switch is an intelligent device? That is what I am telling you. Just the basic things. We will be having a detailed session, so don't worry about this. So here, when a traffic hits on this port, the switch would be checking what cam table, and switch can find that the device C is connected to the port number 0 bar 3. Switch will do what? Switch will only send this data to 0 bar C, 0 bar 3. But what the hub was doing there? At the same time, if you use the hub, when a traffic hits on this port, it is sending to every port. Every port it
Broadcast.
is sending. This is the difference between switch and hub. Okay, switch know that where is the traffic, where is the destination. So how they know that? There is a table inside the switch that is known as cam table. Okay, so by using that by using that table, switch will send the traffic to correct destination. So that is why we call it as switch is an intelligent device. Okay, so this is another network device, that is switch. So we can move to the slide now. Here you can see the switch here. And one more thing, switch is working in full duplex mode, and it can send and receive the data at the same time. Okay, it can identify everything, and switch can do everything. So not like hub, you have to understand these things. Okay, now we come to the WAN router, and it's another networking device. Why we need this device? I told you that if you are having multiple networks, like you will be having a private network, and for example, you are sitting in your home, that means your home network, it's a private network, and you are having, like, if you don't have switch, don't worry. For example, you are using wireless connection. This is your laptop, and the wireless, by using this wireless method, all your device connected to the modem or router, whatever it is, then it is connected to the internet. So this is your private network, right? Not see, here from this section you can say that it's a private network, and it's a internet, another network, right? This would be another network, and this would be another network. You want to go to YouTube means you are going to another network. YouTube network would be like there would be an IP address for YouTube, for example, 1.1.1, and your device is having an IP address 10.1.1.1. Imagine like this. You just want to imagine. So these are different numbers, which means these are different network. If you want to go to internet means you are going to access different network. So without the router, you cannot access different networks. So what is the function of router? Use it to use it to connect the different network. That is what here it is showing here. It is used to connect two different network, and the physical view of the router is like this. You can see the back side here and the front side. So this is the back side and this is the front side, and there would be some Ethernet ports which would be available here to connect to the switches or WAN side or whatever it is. Okay, there would be console port to configure the router, and PowerPoint adapter also would be there. You can see here, And so this is what is the purpose of router? If you ask, if somebody asks you, you have to say that it is used to connect different network. Without this router, you cannot communicate different network. Okay. So even if you have the router and you place that router in your network, it will by default, if you don't have any configuration, cannot communicate. You have to do some configuration also. That configuration part also will be having that session. Okay, don't worry. So the function of router is to connect the different network. So now we come to the firewall. Firewall, why do we need a firewall in a network? If you want to access the internet, you need firewall? No. You see what I'm saying, that you are having an office and you guys need to access the internet there. For example, this is my office. I have a switch here. I have a router. I told you that to access the internet. So it's enough. I have some staffs. So these guys can access the internet. I don't have firewall here. So for accessing internet, we don't need firewall. Or for example, if you have a web server in your network, for example, the website name is www.guinet.com. So this you have hosted here, and you this hosted to the public also. So customer, if somebody want to access this website, you can access without firewall, no problem. If you have a router, you can make that configuration to access this web server from outside. But why do we need the firewall? Firewall, the function of firewall is to protect the network. For example, if you know that hackers would be there in public side, so if this is an hacker and he want to attack your network, there are so many attacks like DOS attack, denial of service, or imagine simply you can say that I don't want to make you like confused. So I'm giving you a small example, like this guy is going to download a file from the internet. Okay, so you will be getting easily the point. So this user is going to download a file from the internet, and imagine that this file is affected by the virus. Okay, so this guy will do the what? He will be sending the traffic to download this file, and this file will be getting downloaded, and this device will be getting crashed, or maybe entire network will get crashed. So here we don't have firewall. If you have the firewall here, okay, you have the firewall in your network after router or before router or whatever it is, or you can replace the router with the firewall also, because the firewall can do the function of router also. By using a firewall, you can do routing as well as you can protect your network, no problem. So okay, now you are having a firewall in your network. Okay, imagine that. So now again, this guy is trying to access this file which is affected by the virus. So he is going to download this file. So the file would be coming here. Once it reaches to the firewall will be getting, it will block that file. Okay, this is what firewall does. So firewall, it's a security device which can protect your entire network. Okay. So this is what firewall is doing, and it is also a networking device. So now we can, here you can see that inbound and outbound traffic, if you are having a firewall, like the hacker is sending the data and firewall will be blocking that. Okay. Now here the definition also, you can see that it is used to control inbound and outbound traffic to protect the network. Now the next device, networking device, is gateway. Gateway, it's not a device, it's a term. It's a term which is used for networking device. Like, if the device is entry also, sorry, gateway, it's an exit or entrance point for a network. Gateway means it is not a device, it's a term. Like, gateway can be a router or it can be firewall. I told you that you don't want to have the router if you have firewall, because firewall can do the routing also. So for example, I have a network. Imagine that this is my network and this is my router, and I told you by using this we can access the internet, right? Here, this is my network, right? So what is the exit and entry point of my network? This guy, right? So here router is my gateway. In this network, you can say that router is the gateway. Why? Because router is act between two network. Like router is acting as an entry and exit point of a network. This is my network and my exit point is also router, and my entry, when a traffic comes to my network, the entry point is also what? Router. So it is known as gateway. Here gateway is the router. Now imagine I have another network. Here I am using what? Firewall. Whatever firewall it is, it can be FortiGate, Palo Alto, Cisco FTD, whatever it is. Every vendor, different vendor having firewalls. Okay, so here also connected to the internet. Now, this is my network, right? So who is the entry and exit point of this network? When a traffic come to the network, it will be hitting, first it will be hitting where? Firewall. So it's an entry point, right? So when a traffic goes out of the network, last where it hits, again firewall. So it's an exit point. So my exit point and entry point of a network is who? Who is the exit and entry point? Here, firewall. So here, who is the gateway? Firewall. So gateway will be getting varied. Okay, it can be router or it can be firewall or it can be layer 3 switch. Layer 3 switch also can do the routing. Okay, we'll be coming to that when we take that sessions. Okay, no problem. So gateway can be anything. It can be router, it can be firewall, it can be switch, whatever it is. So the device which can do the routing can be a gateway. So this is what another network device that is known as gateway. And other thing is access point. Why do we need an access point? See, in companies and all, or even if you consider your home network, maybe you connected your devices to the internet wirelessly, right? You will be having a laptop, maybe you will be accessing the Zoom through your mobile phone. So your mobile phone would be connected to the router. So your modem which is present in your home, how? Wirelessly. Okay, so if you want to access wirelessly to your, if you want to connect the devices to the internet or to the router wirelessly, you need to have a device inside your router. If there is access point inside the router, nowadays you are getting a device in your home that that will have what? Access point too. Okay, that router will be having access point also. That is why you are able to connect your device wirelessly to this router, because it is having access point also inside this router. Okay. So you don't want to think that if it is a router, the device which you are getting in your home is only a router. No, inside that it can be, we can call it as sometime, almost most of the time it will, we can call it as modem. Modem means it will have the router, it will also have the access point, and it will be having some switch port also, switches. Like we can have some ports here, and to have the, if you want to connect by using the cable also, that is also possible in this modem. So because of the presence of access point inside your router, you are able to access the internet. Okay, so if you want to access, or if you want to have the communication wirelessly, you will be having what? You should be having what? Access point in your network. Imagine that the router which you are using doesn't have the access point. For example, this is my office network, and yeah, I am connected to the internet, and these are the staff. And after 1 year, 6 months or 1 year, your staff is saying that they need a mobile phone. They have the mobile phone, so they need to access the internet through the mobile phone also. But you don't have access point here. So right now you cannot give the access wirelessly. At that time, this point of view, or in this scenario, what you have to do, you can purchase the access point separately. Okay, and you can connect this to the switch. Now access point, you will be we will be having a session on this also. Yeah, I just want to inform what is access point. By using this access point, again you can connect to this device wirelessly. And now if this guy want to access the internet, it will be sending data here, now to the switch, then to the router, then to the internet. So if there is no access point in your router, you can add the access point also in your network separately. Okay, so what is the purpose of access point? If you want to have the a communication wirelessly, you have to have what? Access point. This is to connect two or more than two wireless devices. Okay. uh, okay, now these are all, see, whatever we discussed so far, you can see all these devices here. LAN card, this is that wired LAN card, this is wireless LAN card, this is hub, and this is switch, this is firewall, this is router, this is access points. So these are the network devices, examples of network devices, and which is available in the market. There is WLC, so many network devices still there, but we just want to have some examples. We have discussed those things, some general things, and now the next slide, we have to move sorry, IPv4 address, but the time is now 9:15, so it's not good to start the IP address right now, because we will be having 10 points to keep in mind before assigning this IP address. We have to discuss 10 points. So within 10 minutes, I think I cannot even discuss 2 points within these 10 minutes. So it's better to do in next class. Okay, I hope all you guys got the concept which we take the topics today. Okay, if you are having any doubts related to the topic which we take, you can ask, or else we can wind up the session right now. Okay, tell me, guys. It's okay to wind up? Hello?
Yeah, Faisal, it's
Okay, so we can wind up then. Okay, thank
yeah,
you.
yeah. We don't have any notes regarding this class. Can you
Yeah, I'll
help
be
on?
providing that, no problem. Okay.
Uh,
We can provide notes. You are asking notes, right?
yeah, yes, yes, yes.
Okay, we can provide, no problem. Will be providing, I'll be asking to Vishal sir, and we'll provide.
Yeah,
Okay.
it's a better because before class we can prepare and we will come right. It's a better
Okay,
understanding.
okay, guys. Sir.
Yeah.
I'm going to leave. Okay, thank you.
Okay, thank you.
I have a quick question.
Hmm.
Hello?
Tell me, Aziz.
Yeah, so is there any possibility you send us the study material before we even start the class, so that at least we can go through it first
You are also
before,
talking about the notes, right?
Yeah, like a note before we even start the class. For example,
I
Faisal
got it.
said,
Before starting the class, if you get the notes, you are saying that it would be better to refer that notes and come to the class.
yeah. So, for example,
Yeah, yeah.
Faisal said, our next class is gonna be IPv4, right?
Ah. Hmm.
So if we have the notes, the study
Hmm.
material, some of us can go on YouTube, we can check online, and at least to do our own diligent study before we even join the class. So at least by the time we are on the class, it won't look strange to us. So we'll be only coming with like the questions. I
Yeah,
don't know if that make any sense.
yeah, I got that, and I'll be discussing with that my colleague, and I'll let you know. Okay, no, don't worry about this. Okay, we'll be doing something that okay. I want to discuss with that colleague Vishal sir, and I'll be informing the concern which you are making now. So we can do something in favor of you. So it's okay. Okay. I'll be informing him regarding this.
No problem then.
Yeah.